Welcome. This video is going to talk about the idea of chemical bonds and then look a little more specifically at ionic bonds. So a chemical bond is defined as the attractive forces that hold atoms together. And there are three kinds of chemical bonds, and all three formed by some kind of an attraction. It can be attraction between the positive nucleus of one atom and the negative electrons of another atom, and those are called covalent bonds. Could be the attraction between a positive ion and a negative ion, which are then called ionic bonds. Or there's a third type of bond called the metallic bond, which we'll talk about a little later in this chapter, and it's kind of a combination of ionic and covalent bonds. Any chemical bond will always involve the valence electrons of the two atoms that are bonding. You notice above, covalent is going to be attracting one atom, is going to be attracting the electrons of another, and with an ionic bond, you have ions that have gained or lost electrons. Chemical reactivity is really describing this these electron changes. So chemical reactivity is defined as the tendency of a substance to undergo a chemical change. And remember, a chemical change is when atoms rearrange themselves and become new substances, new combinations. Noble gases, way over family 18 or 8A, are extremely unreactive, while all the other elements are reactive. So this tipped scientists off that there was something about a full outer shell having 2 electrons in the s orbital and 6 in the p orbital of the outer energy level that made atoms really stable. And remember, stable means it doesn't take much energy to maintain them. So all atoms will gain, lose, or share electrons to get this stable octet. And that's known as a chemical reaction. And I like to summarize this idea, or the octet rule, as 8 is great, but 2 will do for elements 1 through 5. And 2 will do for elements 1 through 5 because they're only going to have the s orbital in energy level 1 after they gain or lose their electrons. So natural elements 6 to 92, and then all the elements bigger than 92 are going to need 8 electrons in their outer shell to be chemically stable or unreactive. So looking at ionic bonds, they involve positive and negative ions. So just to review, positive ions form when an atom loses 1 or more electrons. And the name for a positive anion is called a cation. I know it looks like cation, but it's pronounced cation. And I remember it's a positive ion because that T looks like a plus sign in the middle of the name. And metals are going to be the elements most likely to form a cation because, remember, metals are the larger of the atoms. That means they lose their electrons more easily than they can gain the electrons. Transition metals also form cations. They usually lose 2 or 3 electrons, but for reasons we'll talk about later, they can lose as many as 1 to 5 electrons. So my example says, use noble gas configurations to show an unstable aluminum atom and a stable aluminum atom. So if you find aluminum on the periodic table, it's number 13, it's in period 3, and it's in group 3A or 13. So that lets us know also that it's in the P block. So remembering noble gas configuration, it says P block, I know it's a little hard to tell. We look back at the noble gas in period 2, which would be neon. That takes care of my first 10 electrons. I fill up the 3s with 2 electrons, and then I come over to the 3p and put my 13th and final electron in there. So that's the unstable noble gas configuration of aluminum. Because it's in group 3A, and as we look at this configuration, we see that aluminum has 3 valence electrons. So it's going to tend to lose all 3 electrons. Because it's a larger metal, it'll be easier to lose those 3 than to try and gain 5 electrons. So its stable configuration we now show as just neon, and these 3 electrons from the 3s and the 3p orbital have been given up, and to show that we just put a -3 charge up here. And it's important we keep the brackets around neon because it's not neon that's lost it, it's aluminum, or an element that now has a configuration like neon, but it has picked up a -3 charge because it's a +3 charge because it's given up 3 electrons in having that stable arrangement occur. So here's a try it for you. I've got 3 questions in here. The first one, which family of metals should be the most reactive and why? Well, most reactive means most likely to lose electrons or the easiest to lose them. And again, the largest ones should lose the most easily, and the largest family of metals is going to be the furthest to the left. So this is going to be group 1, and it's because they're the largest. And because they're the largest, their electrons are furthest out and the hardest to hang on to. How will lead become stable? Will it gain or lose electrons, and how many? Well, if you take a moment and find lead on your periodic table, it's number 82, and you see it's in group 14 or 4A. And so 4A, it's still a metal, so it's still going to tend to lose, but now it's going to need to lose 4 electrons to get stable. And then my final question, draw the electron configuration for barium before and after it becomes stable. And what you might want to do is pause and actually try this here. So before, which is what we consider unstable, and our after configuration that should indicate it's stable, and it should look like some noble gases configuration. So go ahead and pause if you want to try it on your own. Otherwise, I'm going to proceed with drawing barium before, and when I find barium, it's over in period 6, it appears to be it. It's number 56. So I'm going to use xenon, which takes care of 54 electrons, and that means I just need the 6s with 2 electrons in it, and that's my configuration for barium before it becomes stable. To become stable, it's going to lose those 2 valence electrons, so after I'm just going to show it as Xe, which has now picked up a +2 charge. So it's got the electron configuration of xenon, but it's become a cation to do that. So then let's look at the negative ions. Negative ions are the ones gaining the electrons because these electrons have to go somewhere as the metals lose them. They're called anions, and I like to remember that because if you look at the first 3 letters, A and I, that reminds me that it's any negative ion. So nonmetals will tend to form the ions, anions, because they're smaller atoms, so they gain electrons more easily than they lose them. And when a nonmetal becomes an anion in a compound, the element gets renamed with an IED ending. So the cation, no change to its name, but anions, now chlorine ion is going to be renamed chloride, or oxygen ion is going to be renamed oxide. So when you see this IDE ending, it lets you know it's no longer an atom, but it's an anion or a negative ion. So let's take a look at a few questions regarding nonmetals and anions. Looking at your periodic table, which family of nonmetals will be the most reactive? And it would seem like 8A, since they are the smallest one, should be. But remember, 8A is the noble gases, so that's going to be the second smallest family, which is going to be 7A, because they're the smallest family. Other than the noble gases, which we know are not reactive because they have a stable configuration. And then my second question says, how will oxygen become stable? Will it gain or lose electrons, and how many? So if I look, oxygen's a nonmetal in family 6A, so that lets us know it has 6 electrons, so we can expect it to gain 2 electrons to get to that stable octet. And then final question on this page, draw the electron configuration for a nitrogen atom before and after it becomes stable. So beforehand, nitrogen is element number 7, so it's just in period 2. And so I use hydrogen or helium, which takes care of my first 2. And then I know the 2s will have 2 electrons in it. And then when I go on to the 2p, the other 5 electrons, I'm sorry, I don't have 5 electrons left, the other 3 electrons will go into that p orbital, which is why it's in group 5, is because it has 5 valence electrons. So then after, how will nitrogen become stable? It's going to pick up 3 electrons, so this will be 2s2, 2p6, or this is really now got the configuration of neon. And I have to include that it has picked up some extra electrons, so it's no longer neutral, but it now has a -3 charge with it. So I can write the after configuration. I can either just add the 3 electrons and show that it picks up a total of 10 and looks like neon, or I can shorten it to just neon. Either configuration is just fine. So a couple more questions just to try and firm up what you know about ionic bonding. It says, how can you use the group A family number to decide if an atom will gain or lose electrons? Well, because the family number tells you the number of valence electrons. And then you can look and see if it's a metal, that's how many it will lose. But if it's a non-metal, you could take 8 minus the valence or group number, and that's how many it will gain. Didn't leave a lot of space there to write in that answer. Okay, so metals, the valence number or group number tells you how many electrons it should lose, whereas with nonmetals you subtract it from 8 and it lets you know how many it will likely gain. And then my last question is, what is the name of the anion formed from nitrogen? Well, since it's an anion, we changed the end of its name to IDE. It would just be called nitride, which is different than nitrite with a TE or nitrate with an ATE.